Hi folks, welcome to BRK 2112. This is a re-recording of a build session that we did, and unfortunately the video didn't get recorded because of a video feed problem, so we're back in the Channel 9 studios recording this talk. So we're going to walk you through Azure Storage and a set of different features and other work that we've done over the last year. I'm going to start off with a very brief introduction to storage services, and just to give you sort of a high-level viewpoint. There are other sessions that I'll point you to if you haven't, if you need a primer on Azure Storage. But mostly what today is going to be is a roadmap session for blob storage, what's new, and we're going to do a little bit of a deeper dive into some of the security features and the scale and performance features that we've built over the last year or so. We're also going to talk about Azure Files and Azure File Sync, and we're going to give you a brief roadmap update for disks. So we had another talk at Build, BRK 3313. That one is a much more cloud-native application-centric talk, and kind of walks you through building a simple application that's customer-facing and using serverless computing and blob storage on the back end. So if that's something that you're interested in, please check that talk out. As promised, here are the other talks from the previous Build conferences, and those talks will give you a more of an introduction to Azure Storage and Azure Blob Storage that we won't cover today. So when we talk about Azure Storage, what are we really talking about? The first thing is the three core services that make up Azure Storage. We have disk storage, which are your persistent disks for your virtual machines, either your boot disk or your data disks. We have file storage, which is your shared SMB storage as a service. And then we have object storage or blob storage, which is our scalable, high-performance object storage as a service. In addition, we also provide data transport services to get your data in and out of the Azure Storage cloud. And we have a number of different hybrid storage offerings like StorSimple, Azure File Sync, and a recent acquisition called Azure. We're going to dive a little bit into Azure File Sync, but not into the other services. And as I said, we'll spend our time on the first three: disks, blobs, and files. So let me give you a quick intro on data transport and what you need to do if you're trying to get the data first into Azure or out of Azure. We have a service today, the import-export service, that allows you to ship disks to us or have us ship disks to you to get your data to and from Azure. We have another service called the Azure Data Box that's in preview today and allows you to move about 80 terabytes of data in bulk into or out of Azure. That service is in preview and will GA soon. We also announced recently a different service called Offline Media Import, which is offered through our partners and allows you to get your heterogeneous data media like tapes or external hard drives and other things imported cleanly into Azure Storage. So if that's interesting to you, please use the link below or search for Offline Media Import for Azure Storage. So with that, let's kind of walk straight into Azure Blob Storage. And what Azure Blob Storage is it's the canonical storage service that you think of when you think of REST-based object storage in the cloud. You can store and serve all kinds of unstructured data. And the key thing about blob storage is it's directly or indirectly integrated with many other Azure services. So you really, even if you're not using blob storage directly, it's helpful to know, what it's like and what are the underlying capabilities if you're using any of these services shown on this slide. So what we're going to do for the blobs portion of this talk is talk about it in terms of these 5 fundamental pillars and use that as a frame to talk about each of the feature enhancements that we have made and that are coming soon this year. So those are durability and availability, security and compliance, manageability and cost efficiency, scale and performance, and open and interoperable. So to get started with the first couple of these pillars, I'm going to invite my colleague Chris to come on up and talk about durability and security. Chris?
All right, great. Let's talk about durability and availability. So This is obviously one of the key reasons people use a storage service, is that when I store my data, I don't lose it, and it's made available to me whenever I need it. And so Azure Storage offers a few different choices depending on your needs to make sure your data is always available to you and is always preserved. We do this primarily through several different replication options. And so I'll walk through these real quickly and give you a sense of how they work. So the first is LRS. This stands for locally redundant storage. This means that when you store data in Azure Storage, we make 3 copies of your data on 3 different disks, on 3 different servers across 3 different fault domains that protect you against a disk failure or a node failure or even a rack failure. And we make sure we write those 3 copies before we acknowledge your write, and so you know your data is stored and it's highly available. And this provides this highly available, superior to dual parity RAID kind of a write replication. This happens synchronously and it happens before we return. The next option is called GRS, stands for globally redundant storage. In this case, we do the same thing with your initial write. We store it to 3 different copies in your primary region. And then in the background, we replicate your data to a secondary paired region that's out of the distance of a natural disaster, so typically more than 300 miles away. And then we store 3 copies in that region. And this protects us against large-scale natural disasters. And it also makes sure that we can provide highly available access to the data, even if your primary data is down, using what's called a read-only GRS. So that's the third option. That's where we take that secondary copy and we make it available to you to read at runtime. So you'll be able to read from the primary or the secondary, and using both sources we can provide even higher levels of availability SLAs. We're recently added another option called zone redundant storage. So with the advent of availability zones in Azure, we now offer an option where when you store data in Azure Storage in a particular region, we will make 1 copy of your data in each of 3 availability zones in that region. And what this does is, in addition to the protection against disk, node, and rack failure, it also protects you against zone failures. So zones are isolated sections of a data center, of a region to think about, that includes separate network and power sources, separate cooling, and it's even a higher level of availability. So zone redundant storage is available now in 6 regions and will continue to grow and be deployed more broadly. All right, so let's talk about security. So I want to start with one of the most common requests we get from our enterprise customers, and this is about encryption at rest. So many people, they work in industries where they're obligated to meet certain compliance requirements when they store their data, and encryption at rest is one of the most common ones. And so Azure Storage always encrypts the data at rest, but what we've recently introduced is the ability for you to control that encryption using your own key in Key Vault. And so this became generally available in March. Let's just take a quick look at how this works. All right, so we're looking at a storage account here, and you can see if we go down to the encryption tab, that by default you can see your storage account is encrypted, but if you'd like to encrypt it with your own key, it's as simple as checking use my own key, and then you just go pick the Key Vault and the key that you'd like to use to encrypt your data, and then you just save it. And now your data is protected using a key that you control. Behind the scenes, we grant your storage account access to this Key Vault to read and write that key and to use that key to wrap and unwrap. And if you need to revoke that access, you can do that. You have control over the access to your Key Vault. So if for some reason you needed to revoke access to your data, you can immediately revoke access to the Key Vault, and your data in your storage account will no longer be available. So it provides the kind of control that customers need. So that's encryption at rest. We also have a feature we recently released related to network security. And so storage accounts by default are available, their REST APIs are available to all networks available on the internet. But some customers want to restrict who can access their storage accounts just to their virtual machines, for instance, in Azure, or just to their on-premises networks. And so we've added the firewall and virtual network support to storage accounts to support that. So by default, storage accounts are available to all networks. You can instead choose to allow them to be accessed just from selected networks. And here you can choose from a virtual network in that region to make your storage account just available to virtual machines in that virtual network. So you can see here I can pick a virtual network and pick the subnets within that virtual network that I want to allow and add them. And so now this storage account will only be made available to machines that are coming from that virtual network. And this works in conjunction with a networking feature called service endpoint. So you enable a service endpoint for storage, and that allows the strong identity of your virtual network to be passed to the storage account so we can do these authorization decisions. You can also grant access to an public internet IP address range, and this can be used to grant access to the gateways to your on-premise networks, for instance. So that's firewalls and virtual networks. All right, so let's keep going. So we talked about firewalls and virtual networks. Again, this has been generally available since February, and it's been helping a lot of customers be able to start to use Azure Storage. So let's talk about authorization. So this is probably some of the most common challenges we hear from customers about storage account authorization today. The first is that storage account keys, which are the basis of today's storage account authorization, they're all powerful. So if you have a storage account key, you can do anything to the data in a storage account. And often customers have to manage the risk around these keys, and customers can sometimes use bad practices where customers will embed these keys, for instance, in a client application or in a GitHub archive or something else. And once they're exposed, the only way to control your storage account is to rotate those keys. And that means everybody has to reset their configuration. So it's both a security risk, and it can only be complicated to manage. We also offer a solution to grant less powerful access using a SAS token, shared access signature tokens. And these allow you to create a particular token that you can use with URLs that grants just specific access. But again, we leave it up to the customer to figure out how to map particular user identities or application identities to the permissions they should have in a SAS token. And this can be a significant barrier to people getting started with storage. And finally, both of these mechanisms don't have the concept of identity in them. So that means when an application uses the storage account key to access the storage account, we can't tell one application from another. They all just look like someone who had the key. And so what customers are asking for is that they'd like to use this investment they've made in their enterprise identity system. They'd like to leverage these advanced authorization and authentication technologies from Azure Active Directory, things like multi-factor authentication or conditional access policies. And they'd really like to be able to integrate with the role-based access control that's part of Azure that they use today to manage their Azure resources. And so we listened to this feedback, and we introduced recently in public preview support for authorizing access to your storage accounts using Azure Active Directory and Azure role-based access control. So what this really does is expand the existing RBAC mechanisms that you're familiar with to also include permissions and operations on the data itself. So permission to create containers or to modify blobs. And so you can grant people permissions with these specific operations in them, for instance, the ability to be a blob data reader. So this is available in preview now, and we definitely encourage you to check it out. So let's take a quick look at how this works today. So again, we're at our storage account. If we look at the access control tab, we can see the set of resources that have been granted access, the set of users that have been granted access to this storage account. So if you see here, we've got a few users who have the traditional management roles. But if we go down to the bottom here, you'll see that we've granted access to particular users. This customer user down here, he's been granted a storage blob data reader role. And what this gives him is specifically access to the data. By default, users with management permissions won't have access to the data, but by granting one of these specific roles, they're granted access to the data. So, so to see how this works, let's look at the preview of the Azure CLI that takes advantage of this technology. So if you're familiar with Azure CLI, you use the Azure AZ login mechanism to sign in. So let's go sign in here. One of the mechanisms here that's beneficial is that it takes advantage of all of the Azure Active Directory sign-in mechanisms. So here we can support multi-factor authentication or federation to on-premise directories. So you can see now that we're signed in with this Azure account. So let's show what it looks like to use this account using Azure Active Directory Auth. So previously when you used CLI, you'd have to pass in either a storage account key or a SAS token to get access. Now we can just use this special command that's been added in this preview called the auth mode. So you just pass auth mode login. Now you don't need to pass any keys or any SAS tokens. So in this case, I'm going to download a blob from this account in this container called file.txt. So what this is going to do is to use that interactive login that I've already signed into Azure AD with, and it's going to get a token to talk to Azure Storage using that identity. And Azure Storage is going to give me access based on the role that I was granted to that user. So you can see I have a file here. You'll notice that I had a reader role before. If I try to do, let's say, delete the blob, that same token, while it has permissions to read, it's been given a role that does not have permission to delete the blob. And so you can see that here. Okay, so let's talk about identity some more. So just for an example of how this works in code, you can see that this is a .NET example. We're essentially using the same, if you're familiar with Azure Active Directory and OAuth tokens, this uses those same concepts. You retrieve an access token. And now in storage, we just have a new kind of token credential that takes an access token. And now you can just access your storage account using that token credential. So it just integrates into the code you already have for Azure Storage. If you want to look at how this works sort of at the REST layer, we're essentially passing a bearer token in the authorization header, same way you would when talking to Azure Resource Manager, for instance. All right, so this is great. If you're a user, now you can sign in. You can use multi-factor authentication. But if you're building applications, this can still leaves you with some challenges. When you're building applications, it can be real challenging to create these application identities, these service principals. To create a service principal in Azure Active Directory requires powerful permissions, often something developers don't have. And managing the credentials associated with applications is really hard. So you have to be able to generate, for instance, certificates or strong passwords. You have to find a way to back these up securely so they don't leak. You got to find a way to deploy them and store them and rotate them, all in ways that they don't accidentally fall into the wrong hands. And all these things take a lot of work. So it can be expensive and error prone, and you end up with a lot of people writing security code, which we want to avoid. So the Azure Active Directory team has done some great work to help solve this problem using something called Azure AD Managed Service Identities. So the idea here is that you can take your resources in Azure, for instance, a virtual machine, and configure that resource with its own identity. So you can just say, this virtual machine has an identity, and we take care of all those steps we saw before about generating unique credentials, deploying them where they need to be securely, never leaving them where they shouldn't be so a human gets their hands on them. And then in your code, you no longer have to manage these credentials. You just ask for a token, and the infrastructure, in this case in a virtual machine, will know that you're operating from that virtual machine and give you an appropriate token. So this is in preview today, and it's really super valuable for application developers who would like to deploy and use Azure Active Directory in their applications, but don't want to have to manage all the infrastructure and secrets that go along with it. So let's look at that real quickly. So what we show here is that same storage account in the Access Control tab, if we go to the top here, instead of users, you can see that we list virtual machines as a new resource type. And you can see I've got a virtual machine here that's been granted access. And you add these just like you would any other user. So you just search for a role. Let's say storage blob data reader. And instead of users, you can select a virtual machine. And then you just browse your Azure resources just like you would anything else. So you can see we picked a subscription, we picked the resource group, etc. So I've already done this, obviously, for this VM. So let's go look at that virtual machine. This is that virtual machine here. So one thing that we should point out is, how do I enable a virtual machine to have an identity? And that's just simple in the configuration tab of that virtual machine. You'll notice there's a simple yes/no here that says, register this virtual machine with Azure Active Directory. Give it a managed service identity. So you can see for this virtual machine, I've said yes, and it's as simple as that. And now, when I use that virtual machine, so you can see now I can just run the Java program requesting the particular URL. I get an access token from the host, and now I have access to read that blob. So that's managed service identity. Certainly adds a lot to the equation for developers and removes a lot of the overhead and complexity and cost of building applications securely. So, this preview is available today, and we encourage you to try it. So finally, I want to talk a little bit about immutable storage. So our customers, especially in highly regulated industries like the financial services industry, they have requirements to store data and store especially customer record data in a way that is guaranteed to not be modified or changed for some period of time. And so we've introduced a capability intended to serve those scenarios into Azure Storage. We call immutable blob storage. So the idea is that you can define policies around how long data must be retained, or if it's under a legal hold, and then have those things enforced no matter what the permissions of the user are. And so this is available today in preview, starting in preview in June soon, and you'll be able to configure your storage containers with policies around retention. So let's look briefly at how that looks. So let's look at this storage account here. This is a storage account that is running in the preview. That's why the color's a little different. So you notice that we have the, for a particular container, an access policy tab. Now that includes a new immutable storage policy area. So we can add a policy here. And there's two types of policies. One is a legal hold, and one is a time-based retention. So a legal hold is just an indefinite hold for that particular container until you remove the legal hold. And so you could essentially place a legal hold based on the case number, and you could have as many of these as you needed using a tag-based mechanism. And then time-based retention essentially says, when anything has been created in this container, make sure you save it for at least this many days before anyone can modify it or delete it. So if we set a retention policy here of 1 day, we can apply that. And now if we go back and upload some content here, so now I have a file that's been uploaded when that policy was in place. Now if I try to delete this file, that retention policy should prevent us from deleting it. So you'll see we'll get an error that says this operation is not permitted because of the policy. These policies can also be locked. That means no one can modify them, and you essentially are ensured that those compliance policies are enforced for the lifetime of what's enforced. Before you lock them, you're allowed to delete them. So this is good for developer scenarios or just other cases where you don't have that regulatory requirement of never changing the policy. All right, so that's immutability, and I think we can turn it back over to Vamshi now to talk about management.
Thanks, Chris. So Chris covered durability and availability and security and compliance. I'm going to start with the next pillar, which is manageability and cost efficiency. I want to talk about a couple of features we've added very recently here. One of the common asks we get for our storage account support is whether we can actually recover deleted blobs. Up until now, the answer has been no, because when our deletion is permanent. But what we've done is added the ability to enable what's known as soft delete. So you can set a retention policy on your deleted objects anywhere from 1 to 365 days. And will retain your deleted or overwritten blobs for that amount of time. You do get charged for the storage that's consumed for that amount of time, but the nice thing is you have a very simple, easy self-service recovery of your deleted or overwritten objects, either through the portal or programmatically or through a number of different tools. So it's also fully backwards compatible with your existing code, so you can turn this on and know that nothing in your existing blob code is actually being impacted in any way. This is actually GA now as of June 2018. And what we're going to do to move forward is develop this into our full-blown object versioning. So today you don't get a version identifier back, but if you enable object versioning, you'll get a version identifier back for every time you overwrite the object, and you can independently reference each version. That feature is also under development. Another interesting thing on manageability is the ability to monitor your storage accounts and know what's happening. So Azure Storage has had metrics for analytics and logs for deep dive debugging for many, many years now. But what's happened in the intervening time is, Azure has shipped the Azure Monitor feature. And this is a really cool place because rather than kind of going to every different service in Azure and querying for metrics and having a slightly different REST API and other things, Azure Monitor brings all of these services together to one common monitoring surface area. So you get a very complementary, simple metrics viewer experience. You get a REST API. You have the ability to stream the metrics data into Event Hub or archive it into a storage account, etc. So what we've done is integrated Azure Storage Metrics with Azure Monitoring. That functionality is GA now. And what we're working on next is also integrating those diagnostic logs for deep dive debugging into Azure Monitor. So this is all available now, the metrics piece. You can go try it, and you can just look for the metrics on the left nav for storage accounts. Another thing that we launched since the last build, or even the last Ignite conference, is Azure Archive Storage. It is a tier of blob storage that gives you offline storage as opposed to the online storage of the existing hot and cool tiers, but does so for an incredibly low price. And it's really useful for data that you need to keep for a very long time. One thing that's unique about the archive tier is it's fully integrated into the blob service and the blob namespace. So you can take, as a developer, any option and call this API set blob tier to move your data from hot or cool into the archive tier. So you can do this on a per object basis. Once the data is in the archive tier, we actually retain all of the metadata in the hot tier. So you can continue to query the existence of the object. You can look at the metadata on that object, etc. And when you need to retrieve it, you can actually go ahead and retrieve it. In the future, we're also going to add data lifecycle management there. So here's an example of this in a code sample for .NET of how easy it is to set the object lifecycle for a single object. So you have your typical cloud block blob item, and you can go ahead and just call set standard blob tier on that item and define a tier. So let's go take a look at this in the portal. So what I'm going to go do is go into my portal, click on this storage account that I have here, and I'm going to go click on blobs. And you'll see here that there is a container, the web container here, that we used for a different demo and build. I'm going to click into that. I have a virtual folder here called videos. I'm going to click into that. And what you'll see here is a number of different videos, files. But what's new is this access tier that has different things: cool, hot, archive, etc. There's a default tier for your account, which is where the inferred is coming from. That's the default tier for data that lands in your account, but you can then set and move things around in different tiers. So if I go ahead and click here, you'll see the access tier option and the ability to change it to hot, cool, and archive, right? So that's pretty great to be able to do this either in the portal or programmatically, and you're able to kind of work with that. So what about if you don't want to deal with this at an object by object level and just want to set some simple policy? So we have that as well. So if you go down here, one of the things that's going to be going into preview very, very soon, within a couple of days of this recording on June 11th, is lifecycle management. And what that is the ability to set simple policies. So you have a JSON document here that allows you to do things like, hey, if my data is older than 30 days, go ahead and tier it from hot to cool. If my data is older than 90 days, go ahead and tier it to archive it. In this scenario, we also allow you to expire objects when they go older than a certain amount of time. So this feature will be in preview soon and GA this in calendar year 2018. And we'll add the ability to tier based on different attributes over time. So with that, let me switch back. So that's the data lifecycle management feature as we talked about it. Archive storage, GA'd in December, is already available as well through a number of different partners. So if you're using one or more of these partners, we are continuing to build partner integrations with archive storage, which because of the fact that it's the same namespace and it's an API to control, this is actually very easy for our partners to add as developers or for you as developers to add to your services. An example of a customer that uses this in their production services is British Petroleum. They have a service called the Attic Cloud Service, and they store their data in hot, cool, and archive tiers. And they've had good success with adopting blob storage with the tiering for their services. So what's next for archive? One of the things that we're really focused on with archive storage is looking at sort of fundamental research and looking at what we can do. Now, this is not something that is production ready, but I wanted to show you this cool video of some of the core research that Microsoft Research and our partners in university research are doing. So let me go ahead and play this video for you.
We are using DNA as a storage medium for digital data. And the reason we're doing that is because DNA is very dense. You can put a lot of data in a small volume. To give you an idea, the whole accessible internet is estimated to be about 700 exabytes, and that would fit in the size of a shoebox.
So last year, we stored hundreds of kilobytes of data in DNA and fully recovered that. This year, we're working with hundreds of megabytes of data, which means 1,000 times more DNA.
In building the world record, we've worked with Twist Bioscience to synthesize 200 megabytes of data, which is well beyond anything that's been synthesized to date. Along with the collaboration with the University of Washington, we've demonstrated that we're able to recover data built out of 1.5 billion nucleotides.
The growth that we're experiencing in our global data centers is truly astounding. It's a challenge not only in creating new technologies to deal with it, but in actually inventing the new science to form a foundation for the future. DNA storage gives us that new foundation, and this is exactly the kind of problem that Microsoft Research was built to solve.
Of course, it's a few years away from being a product, but it's a pretty amazing thing to look at the research and what goes into trying to build, DNA as a storage medium. So with that, let me switch gears to scale and performance and talk about a bunch of features and feature work that we've done underneath the covers to make blob storage much more scalable and performant. So to give you that insight into it, I need to give you a little bit of a primer of what the Azure Storage architecture is at a very, very high level. So the first thing we have is what we call the stream layer, which is where we actually store the multiple replicas of the data. The stream layer software deals with failures, with encryption at rest, with all of the durability pieces, etc. On top of that, we have what's known as the partition layer. And this is the layer that actually builds the distributed hash table where we store the metadata or your objects, know how to map from your object pointer into the data stream in the stream layer. And it also takes care of scale out, etc. On top of that, you have the front end, which is the REST API front end that you interact with. It takes care of all of the request handling, as well as throttling, etc., and billing, metering, etc., as well. So if you look at these three layers, the front end, the partition layer, and the stream layer, we've done work across these layers to enable some of the performance features. So let's get started actually with the demo and show you what we're capable of. So if you look at the storage limits today, if you go search for Azure Blob Storage limits, you see this thing that says, hey, a single blob is capable of 60 megabytes per second read or half a gigabit per second. So let's look at what that looks like today. And in order to show this to you, what I've done is I've gone ahead and created a Kubernetes cluster so I can generate some load and some stress on a storage account. What I'm going to do here, and let me just go ahead and start that. And let me go ahead and get the pods. So you can see we're starting up a bunch of pods to go generate some load. And what these containers are going to do is try to duplicate a scenario. Let's say you have a video hosted in blob storage. It's not behind a CDN, and all of a sudden the video goes viral, and you have thousands or tens of thousands of people trying to download the video, and you're all coming back to blob storage. So that scenario is what's shown off, what's simulated by all of these containers running on this Kubernetes cluster. All of them spin up. All of them go get that object over and over and over again across many threads to simulate the experience of having lots of load hitting blob storage. So what's happening behind the scenes is that we, as the storage system, gets these read requests for blob storage, realizes that it's a very, very hot object, and starts promoting the object into our SSD cache, and from there into our in-memory caches, so it can give you maximum performance across all of these different front ends. So how do we go look at that performance and see if we're actually getting that? Let's go ahead and go here to our metrics, which actually, this is for the storage account against which I'm running this test. If you go down here, you can click on metrics to get there. I'm going to change some of these parameters. I'm going to change that to the last 30 minutes. I'm going to change it to a minute. And I'm going to go ahead and click apply here. I'm going to select the blob and the egress. So we're going to see how this is going to look and run. Now just this is taking a little bit of time to warm up. So what I'm going to do is change this to last 4 hours so I can show you some runs that I ran earlier, that basically ran the same test. And what you see here is that for every minute, I'm downloading something like 800 gigabytes into these containers. And let's pick a number here. Let's pick So one of these smaller numbers, 773 gigabytes. So what is that amount in gigabits per second? So divided by 60. So this is 103 gigabits per second. So I've been doing 103 gigabits per second off of a single object versus the stated perf goal of 60 megabytes per second, or half a gigabit per second. So quite a bit higher, and this functionality is really pretty amazing. So let's go back and see if we've generated enough load even in our just recently started test. And you can see that indeed we have, in the last minute since we started this test, we've downloaded 970 gigabytes. So it's actually even a little bit more than 100 gigabits per second. So how do we do this, right? And the way we do this is by adding at the stream layer and what we internally know as Xcache. It's an SSD layer that looks at hot objects and starts to promote them from the disk layer into this SSD layer. We also provide in-memory caches at multiple levels at the partition layer and the front end. But at the limit, when you have an object received many, many times, like this case of this test that we just ran, all of your data is served out of that in-memory cache, which is why you're able to get that excellent read performance. Now, this read performance that I just showed you is available in live in GA in all regions already for all of you. So you are able to go run these tests and get this limit. Now, it works up to the storage scale account limits, and your storage scale account limits are 20 gigabits per second, so you'll be able to push object reads up to 20 gigabits per second. Similarly, we're also working on write throughput improvement, so you can get up to the account scale limits for write throughput as well. So this is what we saw, sort of a single 4 gigabyte blob being read from 500 containers and 100 gigabits per second performance. The other thing that we talk when we talk about scale and performance is the per storage account limits. And what we have here currently is a 5 petabyte limit, 50,000 TPS and 50 gigabits per second limit. You have to request this and we'll enable your accounts for you. We're just being cautious in the rollout here. And later this year, we'll have the new limits be 20 petabytes per storage account, 100,000 TPS, and 100 gigabits per second. And so that's the account type, the account limits under which I was showing you this demo. So let's look at that large blob writes architecture also and see what we do, because as you may know from the blob architecture, it's actually much harder to do writes cleanly because that's got to be committed all the way back somewhere versus reads, which can certainly be cached in memory at different layers. So what do we do today when we look at the blob writes? We take any large object, we break it into a number of blocks. Either you do that or we do that for you if you're using an SDK. And then we start sending these blocks up. You can send them out of order, you can upload them in parallel. So when the data comes up, it hits our different front ends depending on which front end the load balancer sends the data to. But what happens behind the scenes is a single object is only served by a single partition server. So that's kind of ends up becoming a bottleneck because all of these front ends then have to go talk to that partition server to make the write commit. So this creates a bottleneck on that server. We do write to multiple streams to try and parallelize, but it does help. It gives you, really instead of 60 megabytes per second, if you've been using this our service, you're probably getting more like 200 megabytes a second or so, and that's because we're writing to multiple streams, but that's not enough. So what we did was re-architect this as follows. We take the same object, we chunk it up into lots of different objects, but now when you upload blocks, what we do is we take that block ID range, the ID that is assigned to the block, and pre-partition it across all of our partition servers. So now blocks that are coming in can go to multiple partition servers and get committed from there, from each of those partition servers. So when you're uploading lots of blocks into your single large blob, you can potentially have all of the partition servers in our region serve your writes. So that's what really gives you this huge potential throughput of either 6.25 gigabytes per second, which is 50 gigabits per second today, or 12.5 gigabytes per second or 100 gigabits per second later this year. So hopefully that was an interesting quick preview into what we can do for you around large blob writes. So let's kind of quickly run through open and interoperability as well and what we're doing there. So as you all know, all of our client libraries are open source. They're available on GitHub. One of the things we've been doing is rewriting or re-architecting some of those SDKs based on an open API and Swagger architecture. We also have a data movement library that is core CLR based. You can use it on different platforms. And we have a number of different tools from PowerShell tooling, tools like AZ Copy and Storage Explorer, to a command line interface that runs really well on Linux and Mac OS as well. So what about the storage re-architecture? What we're doing there is really making sure that we give you a good set of simple access mechanisms without abstracting the service away. And there's a cleaner mapping between your client APIs and your REST APIs. So, and this is done through the Open API spec through AutoRest, and a protocol API is generated automatically. We then add some handwritten code enhancements that we can release as a single convenience SDK. We have a Java and a Go version of this new SDK up and available on GitHub. An example of the GitHub, the Java SDK is below. We're actually doing asynchronous I/O with RxNetty, which is a popular framework for asynchronous I/O, and we're able to do it very cleanly and simply in the Java framework with this new SDK. Another area where we've been doing some work is improving compatibility with Linux applications that require a file system. We have a fuse adapter called for Linux that is now GA, and that allows you to actually mount blob storage as a local mount point on your Linux VM and then access and use it. If you're using S3, either with other cloud providers or with on-premises object storage, we have partnerships with a number of different partners where you can stand up a proxy. They can speak the S3 API, and then you can commit that data. They commit that data as native blob format blob, so our other Azure services can consume them. Other features on this open interoperability thing, we talked about this in our other talk, BRK 3313, but we have static website support, the ability to serve static web pages or single page apps, progressive web apps, things like that, off of blob storage natively. This is available in private preview now. You can try this off of this link, aka.ms static websites. It will go into preview later in June. If you try this and you have any feedback, please, of course, send us feedback to azurestoragefeedback@microsoft.com. The last piece I want to touch on is what we're doing around serverless compute, which is becoming increasingly important as a way of building cloud-native applications. In December, Azure Storage launched storage events along with the GA of the Azure Event Grid service. And what this allows you to do is use data as your trigger to get serverless applications to get them started. So the ability to take the data trigger, have a 1 to n pub sub, and actually be able to deliver that to an Azure function, Azure container, or any other webhook place. So for more details on this, please watch the other talk that's linked below. So to sum up, what we've done with blobs in calendar year 18, or what's both finished already as well as coming soon, we have a number of features across all of these pillars. All of the ones in green here are already GA. The other ones are in preview or coming soon to preview and will GA by the end of the year. With that, I'm going to turn it over to my colleague Klaus, who's going to talk about Azure Files.
Thanks, Vamshi. So the first question I want to answer is, where should I put my files? Manchus and Chris have talked a lot about Azure Blobs, which is the first area that you can put your files. We also have Azure Compute and Disks, where you can roll your own filer, customizing the I/O by spanning disks and delivering exactly what you want, but then you have to manage these IaaS roles. We also have Azure Files, which I'll get into in the subsequent slides. We also have SharePoint Online and OneDrive. So for Office 365 or Information Worker, Enterprise File Sync and Share, that is the suggestion and the best solution to use for that context. And then we still see on-premise file servers or NAS devices. Customers continue to tell us that the amount of storage that they're using in on-premise servers continues to grow. IDC and Gartner corroborate this, showing the forecast and what people have been doing over the last 10 years. It continues to grow. And that's because a lot of workloads still require the lower latency and performance that an on-premise shared repository will provide them. So what is Azure Files? It's a fully managed cloud service. So you don't have to manage individual servers, update them, patch them, and monitor them. We ensure that it's secure with fully at-rest encryption, as well as in transit. And it's cross-platform. Any SMB 3.0 or 2.1 client OS can be used to access, including Windows, Linux, and Mac OS. And we built it for a hybrid world. We have a sync capability where we synchronize the data from on-prem to Azure Files and back. And that caching or sync capability allows you to control what is being synchronized back and forth. We will keep the hottest data on-prem and then cache to the cloud when necessary, or cache to the server, I should say, when necessary. And it's harmonious. Our sync technology basically uses a last accessed time heat map to make sure that the hottest data stays on those local server caches, and that we use the Azure File Share for all other access. So let's look at one use case, general purpose file server. So in this case, we take all these discrete islands of data that sit in different regions or branches, and we synchronize them centrally in Azure File Share. But we do this in a way where we still allow multi-site access to that data for all these different locations. Using an on-premise cache for that access, so we give the same performance and latency that you're using today. Now, one reason why we want to centralize the storage is because that provides the ability to manage, monitor, backup, and restore from a central location. With that, I'll go a little bit more detail into Azure File Sync as a capability. In this architecture, we have Azure File Sync with a single sync group joining 2 server endpoints and 1 Azure File Share. The server in Seattle, if it were out of space, can turn on cloud tiering, which is the first capability, where we keep the hottest data resident, which is represented by those yellow icons, and then we tier off the contents of all the gray iconed files. But they still show up in a directory listing, so the namespace is still there. If an application or user attempts to use one of those files that is not present, we quickly recall that data to fit that read request or that write request. The second capability is multi-site sync, where any changes that are made to either one of these server endpoints or to the Azure File Share is synchronized between the other nodes. And so you can access it as a single namespace across all those different endpoints. If we were to lose the server in Seattle, the recovery would be as simple as standing up a new physical server or virtual machine, attaching it to that same sync group, and allowing the contents to rapidly come down as far as the namespace. We then address any recall attempts just in time, as we also do background recall to fill up that cache. As I mentioned, we have direct cloud access, so you're not limited to accessing the files and directories on the on-prem servers. You can also access them in the Azure File Share directly. Now at present, we're in preview with Azure File Sync, and so the access of that Azure File Share is limited to SMB if you have sync enabled, even though you can also access the Azure File Share over REST. So we'll be adding that functionality later. And again, we integrate all the storage up in Azure File Shares so you can align with Azure Backup or third-party data management solution to back up and restore that data. With that, since this is a build conference, I wanted to get a little bit more technical and talk a little bit about our architecture for Azure File Sync itself. On the top left, that box is our storage sync service, which is a PaaS instantiation. The lower left is the server agent, which runs on the Windows Server 2012 or 2012 R2 or 2016 server. On the right, we have the Azure File Share integration with Microsoft Azure Backup, MAB. So the first learning I wanted to mention is the checkpoint that we had to add to our background worker process, where we wanted to make sure that if it was a long-running background task, we had restartability so we wouldn't have to start from the very beginning. The second learning was how we think about state. The state that the sync service, storage sync service writes, which is off to the right, we had to consider whether it was persistent or temporary. An example of temporary state is the sync database that exists on every single Azure file share, as well as every single server endpoint. Now it's temporary because we can rebuild that sync database because the authoritative source is the Azure file share store. The next learning is that if you look from our service to the Azure file share, we use both file REST as well as SMB. And we do that because there's different semantics and different capabilities between those two protocols. So we use both to give the best possible experience at the lowest cost. Now looking at the bottom, the server agent, which runs on the Windows Server machine, consists of a bunch of engines as well as a filter driver, which talks down to the sync route, which is part of the file system. We also make use of a USN journal for change notification, as well as the syncDB or sync state. The last learning I wanted to mention was the shared access signature, which is what we use for access. We manage the SAS from the service, supply that to the server endpoint. It uses that SAS to then access the Azure file share. And so it has a specific time to live before it expires, such that we can control access through time as well. Now with that deep dive, I want to move on to the next use case, which is a very common one for Azure Files, which is migrating applications to the cloud. The promise of Azure Files as an SMB 3.0 or 2.1 compliant shared repository for data is that any existing application you have on-prem, which makes use of a NAS or file server in that fashion, can be lifted up to Azure with minimal changes. So you can move the storage to Azure Files first and then direct your on-prem compute to that target. Or you can do the exact opposite and move the compute to Azure first and then over a VPN or express route access the storage on-prem. I also want to mention that later this year we are adding AAD and AD authentication and ACLs to Azure Files to provide a true end-user authentication and accessing scheme, as well as also providing an easier way to lock down your resources for workloads. The third use case is integrating modern applications. Now I mentioned that SMB 3.0 or 2.1 can be used for Azure file shares, but we also support the file REST protocol. So after you lift and shift an application to Azure Files, you can then start to rewrite components of that application using the file REST protocol to modernize it. And that allows you to access that store from different Azure regions or different over-the-internet access points in a much more seamless fashion. And we basically provide library support of the file REST protocol over whatever language and SDK that you wish to use. The fourth use case is really a primary use case for Azure Files, which is that shared data repository. If you have a scale-out workload or one that has HA based upon multiple instances, you can make use of the shared usage of an Azure file share to basically make that very inexpensive. A good example of that is a design pattern we see happening a lot with Azure Files, which is, for instance, FTP or SFTP, where before we had Azure File Shares, customers were setting up a single VM with disks to back up their storage. What we found is that a lot of the customers started switching to using stateless VMs for their FTP server, with Azure Files as the backend as their shared repository. The Azure File Share itself is durable based upon the way we provide durability in Azure Storage all up with a minimum of 3 copies via LRS. With that, I want to provide a little bit more of a specific example. In this example, I'm going to use both Ubuntu, Docker, and Azure Files with a WordPress instantiation. Now, luckily in GitHub, somebody has published a quick start template where all I have to do is click on this blue button, and it will deploy an ARM template which asks me to fill out a subscription name, a resource group, and a location, and that's pretty standard for any ARM resource, as well as a storage account name, an admin username and password for the Ubuntu VM, and lastly, a DNS name for that Ubuntu VM. Then I also have to specify a VM size, an Ubuntu version, and the terms of use, and click Purchase. Now this ARM template takes about 5 minutes to run, so I went ahead and cut out the middle portion. Once it completes, what I'll do is take a look at the resources that have been built, and it's finished. And so looking at the resources, what I have is a storage account, a VM, the Docker extensions for that VM, IP address, network interface, and the virtual network that ties it all together. So now that I've deployed my basic solution, I'll go to that storage account. And then within that storage account, I'll go to the Files resource type, and I'll create a new file share. And that requires a name and optionally a quota. If I don't specify a quota, then it's just the max capacity of the share that I'll be limited by. So now I've created my Azure file share. Before I leave this page, I want to grab one other bit of information, which is the connection string that I'll use for my Ubuntu VM. So this gives me the connection string including the storage token or access token. So now that I have that, I can move on to the next stage. So for that, I've used PuTTY to connect to my Ubuntu VM. And when I first entered it, I had to create the directory that I'm going to use to mount my Azure file share. So I made the directory, and then after that, I went ahead and mounted the Azure file share using that connection string that I previously copied with one change where I add in the /mnt azfilemnt path. Now I can run the mount command again, and the bottom line shows me that I have successfully mounted the Azure file share to this Ubuntu VM. So now that I've done that, now I have to configure Docker. So as part of that ARM template, it gave me a YML file, which is what I use for Docker. So I'll go ahead and run the docker compose command, and this takes about 8 minutes. So just like a good cooking show, I've cut that portion out as well. And after that 8 minutes, it led me to complete the Docker configuration. And it shows me that I have 2 Docker containers running, one that's running my database and the other that's running my Apache website. So now I've configured Docker. The next step is to configure WordPress. So I'm using the public IP of my Ubuntu VM. So I connect, and then it gives me the initial experience to configure WordPress. And this takes about 5 minutes, which I've also cut out. But it asks me information about login, site name, configuration parameters. And once I finish that first time experience, once I log on, using the correct username and password, what I will see is the admin experience of WordPress. And remember, this WordPress is running in a container, which is running in an Ubuntu VM with an Azure file share backend. And so now this is my WordPress site, which is running in this topology. So now the last thing I want to do is go back to the Azure file share and look at the backend. So for that, I'll go back to the storage account that I previously was using. And it was empty when I first started this process. And now when I look at the file share, I'll see all the different files and configuration pieces that WordPress requires. And as far as time it took to do this, it was about 20 minutes end to end when I set up this demonstration. With that, I'll talk a little bit about the files roadmap. The highest priority items that we have coming up is file share snapshots, which we already GA'd previously this year. We have a backup for Azure files, which is in preview right now. We're heading for GA sync this quarter that we're in currently. We're looking to add AD and AAD integration in ACLs before the end of the year. Both larger file shares from 5 terabyte limit that we have today to 100 terabyte limit, as well as higher performance for files up from 60 megabytes per second up to 4 gigabits per second, is due by the end of this year. We're also adding an SSD offering for files. And I did want to mention that we launched ZRS in 6 zones in the previous quarter. We're looking at adding NFS support, as well as cross-region cloud-to-cloud sync with Azure File Sync. Now I wanted to change gears and talk a little bit about Azure and NetApp. Azure with NetApp is a fully managed service. It's not just a bolt on the side, which means that the integration is with our ARM portal that you would use to manage any Azure resource. It's sold and supported directly from Microsoft, and it's done in a way where you have the complete power of ONTAP, whether it's using SnapMirror or providing an NFS v3 or v4 share. So it's truly hybrid where your on-prem NetApp appliance as well as your Azure NetApp functionality can integrate quite nicely. Now, as we've done this, we've made sure that any security promises that Azure makes is upheld, including data at rest encryption, as well as role-based access control. And we have a limited preview coming up either in June or July of this year. Now with that, I'll give a short demonstration. This is a cut that we took before we changed the names as well as the experience, but it shows you the flow. So in this case, we're calling it NFS volume, which will change. And notice this is through the portal. But as I go through the wizard, I have to add a name, add a file path that will be used. And then also a service level. In our preview, we will only have one service level, which is SSD backed, provision size, and then some standard information, which is typically the resource group, the location, and then the virtual network, which is unique for the NetApp offering versus storage accounts, if you're familiar with deploying those. So after I hit create, this takes some number of minutes to deploy, and after I'm done, I'll basically drop into the UI to then configure and manage that. Now at this point, I could also use PuTTY to connect to that resource or to a VM, which will then connect to that NFS share to show you what that looks like from a concurrency standpoint. But if you've done this, it's no different than that. So with that, I'll hand it back to Vamshi to bring us home with disks.
Great. Thank you, Klaus. So we've talked about blobs and files. Let's kind of quickly wrap up with Azure Disks. So Azure Disks come in 2 flavors, Premium and Standard. Premium is SSD backed and gives you provisioned and high throughput, high IOPS and low latency. And Standard disks are hard disk backed. We have a method of managing them called Manage Disks, which is really a very seamless way of getting allocating disks, managing them independent of your VMs, attaching them to VMs, etc. While the older method of managing disks does exist, we highly recommend that everybody using VMs anew in Azure do indeed use managed disks. Disks also have some pretty interesting differentiators. We guarantee a 0% annual failure rate on our disks because the underlying system, if you recall the architecture we talked about, is exactly the same as that for blobs. So you get, when an I/O in your virtual machine completes, you're getting 3 strongly consistent copies on 3 different disks, on 3 different racks for your Azure disks as well. We also have a cache that's on your host machine, and it's completely transparent to the VM, that uses the local SSD as a large read cache, which really makes your read workloads very low latency and very performant. And finally, you can build the largest disk systems today in the public cloud with up to 80,000 IOPS, up to 2 gigabytes per second on Azure virtual machines using premium disks. One of the things that I want to talk about is a quick roadmap and what we're doing here. And you can see here that some of the features that we have, it's supposed to say calendar year 2018, is moving managed disks across subscriptions and resource groups, portal support for conversion to managed disks. You can do this today with the PowerShell or command line interface tooling, some additional work around incremental snapshots and differential APIs, etc. We also launched the preview of a service called Standard SSDs, which is kind of tries to really give you a sweet spot of a price point lower than that of premium disks, but much more consistent latency and performance and throughput than standard disks. So standard SSD is in preview now, and you can go use it in a few regions until GA later this year. In addition, we're continuing to improve performance and throughput for standard managed disks and premium managed disks. One of the biggest feedback points we get is the size of 4 terabytes. So by the end of calendar year 18, standard and premium managed disks, and indeed standard SSDs as well, will have a size of 32 terabytes is the maximum disk size you can create for a single disk. Some quick things on best practices for disks. We always recommend that you use premium disks for all of your mission critical workloads. There are some edge cases where if you have lots of cool file data and you know throughput or IOPS isn't a priority there, you can certainly use standard disks, but we highly recommend looking closely at premium disks for your workloads. As I said, we recommend using managed disks only for all new workloads. Because of that 0% annual failure rate for redundancy is not necessary. You may rate for performance, but you don't need to do this. Now keep in mind that durability is not the same thing as a backup. You may still need to use Azure Backup or one of our partner backup solutions to make sure you're getting consistent point-in-time backups of your virtual machines. On the performance side, we do offer a local SSD. That's what you see listed when you look at the Azure Virtual Machine lists. We recommend that you use that local SSD for things like TempDB and other things, but know that that SSD is ephemeral and is not guaranteed to survive across reboots. You should also enable host caching where appropriate for better performance. And when you're designing these systems with disks in them, understand the limits of virtual machines as well in addition to the disks. We have limits on virtual machines, IOPS and network throughput, etc. You might have a lot of disks, but you might be bound by the limits of the disks. So let's wrap things up. In summary, we've launched a ton of new features with blob storage. This really allows you to enable and build serverless architectures and app development, modern app development on blob storage. All of the security and compliance features that Chris talked about really make blob storage more suitable for your enterprise data workloads. As you saw with our demo with our Kubernetes cluster, you have fantastic performance and scale with your blob workloads. And the archive tier and the data lifecycle management policies and all that continues to make your blob storage the most cost-efficient place to store your unstructured data. On the files front, Klaus talked about Azure File Sync and how you can use that to really have multi-site sync and collaboration and really enable your Windows file servers to bridge to the cloud. He also talked about the scenarios around allowing applications and others to use file shares as a really foundational building block for your applications. And then on disks, we talked a little bit about the disk scale and performance improvements and the standard SSDs features that are in preview now. If you have any questions at all as you watch this talk, please don't hesitate to reach out to us at azurestoragefeedback@microsoft.com. We're happy to take your feedback, your requests, your questions, and get back to you as soon as possible. Thank you again for watching this video.